Namaskar my dear friends. So we have already seen the DC-DC converter, which is very high efficiency switching regulator for different applications like HART modems or automation, building automations or distributed control systems, power supplies and all. And this was the part number that we had actually explained, like ADP 2360, right? So what were the different applications that we had seen already? This can be utilized in HART modems and building automations, distributed power supplies, industrial control systems. We have very high input, and low output current requirements in those kind of systems, where you need to have, let's say, 50 milliamperes of current is required or 20 milliampere of current is required. So these kind of systems, this particular power supply can be used very easily, right? There are other applications like SCADA systems. There also a lot of sensors are used where you need to have a separate power systems. That's the reason we are going to use this, right? And we had already seen the complete product design and development, like what is the data sheet says, how to design different applications or parameters. And using this particular applications circuit, we had understood what were the different items, basically input capacitors, output capacitors, the inductor values, and the limiting current resistor values, right? And the soft start, capacitor values. That all these things we have understood how to design them for your particular voltage output, right? So what we'll do now is we'll try to understand the implementation. So I have done 3 implementations for you. First of all, this is a fixed regulator, fixed version. So this is going to give you 3.3 volt output with 50 milliamperes of current. Like it is set to 100 milliamperes of like current at I peak. So it will give you half of that, that is 50 milliamperes, right? So as you can see, we have a input connector here which is going to take 12 volt supply. So this is my 12 volt input, and we have two capacitors used here, like 10 microfarad in addition to 0.1 microfarad. So both the 10 microfarad capacitors, you can have a 35 volt rating or even 25 volt rating, no problem. 0.1 microfarad you can have 50 volt rating. Okay, I have pulled my power good output with 20 kilo ohm, and I have tied it to input voltage because it can take up to 60 volt input, no problem at all. Enable, I have made it permanent enabled by tying it to the input voltage. Okay, coming back to the output side, we have the inductor selected, which is 330 microhenry. I have selected. This is a part number 744. You can take this part number 744066331. This is from Worth Electronics, a very good inductor that is used for this power supply design. We have the same output capacitors, 10 microfarad, 10 microfarad. If you want, you can utilize little bit higher values as well, like 22 microfarads, but this will be sufficient for your low end applications. And we have output connectors. So the input connector and output connectors are little different, so that you can have a input and output proper understanding. Otherwise there may be a mix up, right? So this is your output and this is your input. Okay, coming back to the output capacitor values, you can have 10 microfarad, 10 volt, or even 16 volts would do. Even 25 volt you can go ahead. Same way this one, and this one you can go ahead by 50 volt, which is more easy. Okay, so this was the first application that we had designed with fixed version of ADP 2360 regulators, that is switching regulator, which you can see the complete part number dash 3.3 means it is fixed version of 3.3 volt output. Okay, let us take the next example. All the things you can keep it same, but this is going to be 5 volt fixed version. Okay, so you can have like capacitor values and all these things same as it is. Inductor values I have reduced it to 220 microhenry. Okay, and you can take up the part number, that is 744071221. I'll suggest you to keep the saturation current around 300 milliamperes. Okay, and the current rating around 200 milliamperes or more. So that is more than sufficient to have a complete design of this particular regulator. Okay, so basically you can take up to around 500 milliamperes also, or 700 milliamperes also for that reason. Okay, Rest all other values you can keep it same as you saw in the 3 volt settings. So the connectors I have kept it same, all output and input connectors, and plus current limiting I have put it 365 kilo ohm to make it I peak across the inductor, that will be 100 milliamperes. It means the output current that you will be getting, which is I out, that will be your half of this, which is going to be 50 milliamperes. Okay. Coming back to the important one, which is going to be adjustable type. So adjustable type, in adjustable version of ADP2360, what you can have the option is input capacitors and all I have kept it same, okay, and it will also work as it is, no problem. We have input connector here, we have V input here, okay, which is 12 volt taken, and output voltage I have taken it 9 volt, okay, 9 volt, and this is my output connector, okay. Coming back to the design of feedback resistors, as you can see, we have a feedback resistor of 316 kilo ohm and 30.9 kilo ohm, that is your RFB1 and RFB2. So this is going to be connected like this, okay. So this was designed based on the values that you had already seen. What was that? We can just have a look in the formula of this feedback resistor design. So this was the thing that we had, right? So we had V output is equal to this much. So let's say V output is 9 volt. In that case, what you have to do is 9 must be equal to 1 plus RFB1 is, let's say it is to be calculated, let's say, and this is, let's say, 30.9 kilo ohm I am taking, multiplied by RFB falling was 0.8 volt, okay. So using that you are going to get RFB1 is approximately 316 kilo ohm, okay. So this is how it has been set to 9 volt using these two resistors of 30.9 kilo ohm and 316 kilo ohms, okay. Coming back to one of the more important parameter, which was the peak current setting. So peak current setting, if you keep that RITH open, then it will be 50 milliamperes, and similarly as you keep on increasing these values like 1500 kilo ohm or 825 kilo ohm, something like that, then you can set these kind of values, right? If you short circuit it, then you are going to get 140 milliamperes of maximum current, right? And this is peak current across the inductor, so I out will be less than half of I peak, okay. So this is how we have designed this particular regulator, which is going to give you 9 volt 50 milliamperes of current at the output, okay. So hope you have a good understanding of how you can play around with different parameters to design your different output voltage based on the feedback resistors. If you want to have a output voltage, let us say 12 volt output, and here your V input is going to be, let's say 18 volt, okay. So in that case what you can do is 12 volt output you have to set same way, V output is equal to 12. In that case 12 must be equal to, what was that, the formula was, we have V output is equal to, let me just see the formula, 1 plus RFB1, like I'll put it here, it will be easy for you, okay. So this is the formula that we have to understand. So in that case 12 is equal to 1 plus RFB1, so I'll just keep it RFB1 to be calculated, and RFB2 I'll just use 30.9 kilo ohm, right, multiplied by 0.8, which is VFB falling, okay. And in that case you can calculate the particular value of RFB to get your 12 volt output at this particular place, right? And you can utilize the same inductor, that is not a problem, it will give you a proper output at all. Alright, so with these three implementation we are going to end this particular workshop about switching regulators for these various applications where we needed to design power supply for various control system supplies, where we needed a lot of sensors like pressure sensors, temperature sensors, ambient pressure sensors, proximity sensors. Lot of different kind of sensors are there which require a separate power supply design, and that's the reason this particular IC was introduced from our training purpose, okay. If you do have any questions or regarding any other ICs that you are looking for to have this kind of application circuits, then you can put down your questions in the comment box and we shall be able to answer you out. Thank you.